Greetings. We're going to show you how to get a best fit regression line here. Now in this case, we're using our raw data, which is time and distance for an object accelerating down a ramp. You recall, that means for distance and time, we're using the second kinematic equation, which is a quadratic. It's got the little squared there, that's quadratic. And for us, the computer's going to give you this right here. It's going to give you this form, where the coefficient next to the x is called a, and the coefficient next to the coefficient next to the x squared is called a, coefficient next to the x is b, and the constant is c. For us, these are the related variables. The structure is the same, it's just some of the names have been changed. This right here, a, becomes half of little a, the acceleration. B and C for us are really 0. So we're going to ignore, no matter what the computer gives us for these, we're going to ignore them anyway. We just want this number here, which will represent, or this number is what the computer is going to give us, and it represents half of the acceleration. So I'm going to do an Excel first. If you have access to Excel, that is what I would recommend that you use for this sort of thing. If you do not, I'll show you in a moment how to do it on Google Sheets. So first thing we do is highlight our data, our times and our distances, and go to Insert, and find the little picture of a scatterplot, and click on that, and choose this one. And here's our scatterplot. And you can see the slightly curved shape. And by the way, you might notice the data that I'm using is not exactly the same as yours, because I deliberately changed it because I feel like doing your homework for you. This is how to do this, not let me do this for you. So I'm going to right-click on one of the data points, any one of these little blue dots. Just right-click on it, and you'll see a thing that says Add Trend Line. We'll do that. Now it's going to default to a linear trend line, which in this case is not what we want. In the next video, I will show you how to, we're going to linearize the data using t squared over 2, and we will use this, but not right now. We are going to use a polynomial. And notice the order of the polynomial is 2. That's math speak for this number, the exponent, is 2. I'm going to tell it to do all three of these things down here actually. I'm going to tell it to set the intercept, and I want it to be 0, because let's face it, if it takes 0 time to go down the ramp, then you must go 0 distance. So we're just going to go with set intercept at 0, display the equation, and what the heck, we'll display the r value as well. Now ultimately here, once we do that, we have the number we want. It's this guy right here, 0.8583 according to Excel, and that represents half of your acceleration. So you notice it's the coefficient they put on the x squared. So it's this number right here, which represents half of the acceleration. So in order to get the acceleration, we would simply double that number. So whatever 2 times 0.8583 is, will be our acceleration. And in fact, off to the side here, you can't see me doing this, but I'll punch it up on the calculator. 0.8583 times 2, 1.717, we'll say. So that would be my acceleration, 1.717 meters per second squared, of course. Now, on Google Sheets, it's a little bit more annoying, to be honest with you. Here's what we need to do. First of all, before we have our data, but before we do anything with it, I've discovered through playing around with this that the best way to do this is to get an add-on. They're free. It's like getting an app for your phone. Go to add-ons at the top here. Now, mine's already there. It's called Power Regression. I already added it on. But what you'll do is go to Get Add-ons. Click it. In the little Search Add-ons box, just type in Power Regression. Hit enter. There it'll be. Now in my case, it has a little check mark because I already got it. You will want to click a button over here that has a little plus thing. You're going to add it to it. It's free. It just loads into your thing. And then at that point, after it happens, your screen will look like mine in the sense that you will have this add-on right here. And what you will do, once you have the add-on, is highlight the data just like in Excel. Go up to add-ons, click on it, find ours, power regression, and go over to create Scatterplot with Trendline. Now we're trusting this program because it's going to automatically default to it. In fact, what it does is it tweaks both the exponent. So you notice this isn't just a straight up x squared, it's x to the 2.034. Close enough. So it tweaks everything to make it fit. It's fine. It'll work for us for now. The number we want, once again, is this number right here, the 0.7931. If we use that number and we double it, 0.7931 times 2, we can use that as our acceleration, 1.586. Both are probably pretty good data points. We'll have pretty good pieces of information. 1.586. Now let's compare it again to Excel. Excel's was 1.717. I think either one would probably be a legitimate one to go with. Let's see, the R squared value here is 0.9836. For the Excel one, it was 0.9792. So you can go with it, but the problem with this is that it messes with this exponent as well. And that's not necessarily, what we want, because the physical law isn't, doesn't have a variable exponent. But we'll live with it. So I would accept either one of those as an answer for my acceleration. This 1.586, or from Excel, the 1.717. Next video, we'll talk about linearizing it, and we'll see if we get better results, or different results at least.